So the next thing that we want to look at is how to find the domain of a function. And we've actually already done this when we were looking for exclusions in the denominator. So this is somewhat of an expansion of what we've already done. So for the first one, I noticed that it is x squared plus 3x minus 17. Now, remember, there's no radicals in this problem, and there is no denominator. So when that happens, it's going to be the set of real numbers. So it's going to be all real numbers. And then make sure that you know how to write that in interval notation. So that would be from negative infinity to positive infinity. So we want to work our way down. So when I'm looking at the next one, remember what we talked about before, the denominator can never equal 0. So the first thing you want to do is you're going to set the denominator equal to 0. I want to solve for x, so I get x squared equals 49. The opposite of squaring something is taking the square root. And remember, when you take the square root, you have to take the plus or minus on the right side. So your answer is plus or minus 7. So that means that your domain can be any value except plus or minus 7. Now, how would you write that in interval notation? Well, we know that it's going to be coming, if I might draw a number line to kind of help me out. So there's my minus 7. There's my positive 7. It cannot be these numbers, so they have circles around them. So I would be coming from negative infinity to negative 7, and then I would have the union from negative 7 to 7, and another union from 7, well, that's crazy, from 7 to positive infinity. So that, of course, I crammed that in there, which is crazy. Now, the one at the upper right corner, we have a radical sign. Now, it is a square root, so it's an even root. So when we do that, we know that we want to, it's going to have to be greater than 0. So I'm going to take 9x minus 27. It's greater than or equal to 0. And then I'm going to solve for x. So I'm going to get 9x is greater than or equal to 27. And I'm going to get x is greater than or equal to 3. Again, you can tell me that it's x is greater than or equal to 3. And if you do it in interval notation, this time it is equal to, so it's 3 to infinity. Remember, if you have a little problem, all you have to do is draw a number line. There's your 3. It does include it, and then you shade to the right. So now, of course, there's got to be a tricky one. Just wouldn't be life without it. Now, since we're in the denominator cannot be 0. So it's kind of like what we just did in the previous one, except this time, since we're in the denominator, it can't equal 0. And because of that, what we're going to do is we're just going to set it greater than 0. So I'm going to have 24 minus 37 is greater than 0. Now I need to solve for x, so I'm going to get minus 3x is greater than minus 24. Now remember, when we divide by a negative, we have to flip the inequality. So x is going to be less than 8. Now if you're having it still a little bit of difficulty, just draw a number line. You put an 8. It does not include it. You're going to shade to the left. So in interval notation, this would be from negative infinity to 8, not including it.